All right, hello. This is Vince Linux. Um, yeah, probably a thing you want to know. Oh yeah, and thanks to Daniel. Like half this is his from last year. Because why reinvent the wheel? Anyway, who am I? Not a real person. I'm Stella. Second year. I'm bringer of hell for ISTS. For Linux. So sorry. Allegedly the junior ops lead. Um, I do stuff with networking and do stuff with system administration. Um, you know, hire me. I have years of experience giving presentations, it turns out. Um, Also, my voice is roasted, so keep that in mind. If I start having a coughing fit and go outside, just shoot me. Um, anyway, first thing is to basics with Linux is how to help yourself, right? There's no point, well, if you're just gonna ask someone else for all the stuff you're gonna do, there's not a lot of help there. There's not a lot of point there. So, man pages. This man short for manual. You just type in man and then the command or the config file, and it has all the stuff you need. You have apropos or apropos, whatever. It's like reverse search. So if you say like I don't know what command does this thing, you put in say apropos like mount, and it'll tell you the mount commands how you mount a file system. Um, yeah, which is super nice. Also, Google helps, and most commands have a TAC H option or a dash H option. Um, that is also very helpful. And yeah, so going to the file system real quick. This seems all very complicated, right? Like, I think we can all agree that's a big list of things. Let's get a couple things out of the way. First of all, these, not real, don't really matter. SRV, sort of real, no one uses it anymore. Mount, almost, unless it's something mounted in media, empty. Don't matter. Also, not all files are real. Stuff in dev and proc and also /sys, which isn't on this list, sys sys. They're just not there. They look like they have files, but they're not really files. Their dev is block device or other types of devices like your mouse, which I think we all agree a mouse is not a file. And proc is for processes. If you want to know more about that, Joe Batze has an excellent presentation on proc from, I believe, last spring. Go listen to that if you want to know more about proc. I'll touch on it a little bit. And sys is like stuff for the kernel. And some of these also just the common directories that are vestigial from past Unix. If you ever work with BSD type systems, you'll notice a pretty big difference there. Especially more ones are SRV, which again people don't reuse anymore. And also, if you look at sbin, I don't know why I put it on boot. That's not true. Sbin, lib, and bin, those are almost always just a symlink to /user. Boot is not. Boot is its own partition. Because those are symlinks in most modern Linux distributions, not all, admittedly, they kind of are removing a redundant folder. In older Unix and BSD still, there's a distinction between user bin and normal bin. To us, it doesn't matter. Also, /sbin is for like static binaries, which is kind of misleading. It might not be correct, but it's for like system stuff. Basically, if it's required to boot the machine, it should be an sbin. And usually the administrator-only tools as well. Anyway, so proc and sys. They're virtual file systems, sort of. They're not real. But aren't all file systems virtual? Sort of. But these are used to access system information, because the only way to access anything on Linux is a file. Because everything's a file, you have proc and sys. Things look like files that kind of act like files, but they're not. Theoretically, you could open up some stuff in like your text editor of choice, but that's dumb. Normally, it's overwrite the file using like T, or you just pipe it in, which we'll talk about in a minute. They look like files, but they're not. And they will only take certain values as well. There's proc. Proc is a directory has a directory for each process by the process ID. This, as you can imagine, is very useful for, what is this process? What is it doing? Also, there's other directories too that, for basic purposes, don't matter. It's mostly read-only. There's not a lot you can change, but you can go through and you can see all the stuff that's there, which is super nice. A bunch of metadata about processes as well. You can go through. You see, how do you put it? You have stuff like the executable that's running, the options it was given, the working directory for the executable, etc. It was all super nice, useful for both system administration and security. Like, what the hell is this thing running? Why is it taking up half my CPU? There's /sys, just mostly data on the hardware you have. Stuff like weird PCI configurations are in there, a couple other things, and a bunch of kernel stuff too, like stuff with IP forwarding and so on. Anyway, moving on to file permissions. They always seem really intimidating to newbies, which is, I guess, fair, but it's not that hard. Files and directories have 3 items. They have the user that owns them. They have the group owner, the group that owns them, which is usually the same as the users group, but they can be different. And the permission for others, anyone who is not a user or a group. We're ignoring ACLs, which is access control lists, because those are confusing and not very relevant to many situations. This is how I learned. There's a post-it note which I worked on with my dad in elementary or middle school. Admittedly, it probably only makes sense to some people, but I'll go over it. Each read, write, and execute is a bit, and you're just representing it as a number. Sometimes you see it as you see up top with dashes with the X and W and R. That's the human readable version. But honestly speaking, first bit is executable, so that's 1. So if it's an odd number, it's executable. Directories are always executable. Don't question it. Next one is write. That's 2. So if you can subtract a 2 from it, you can write to it. And then the last bit's 4. So you subtract 4 from it, or if it's at least 4, better way to say it, you can read it. Seems, if you have an intuitive understanding of binary, if you have a slight intuitive understanding of binary, it's not as hard to understand. They're not just random numbers, is the point. Next up, file descriptors. This is not written by me. Basically, you have 3 that matter. It's less important to know what the word file descriptor means and more just the things that are file descriptors, which is standard in, standard out, and standard error. Standard in is piped into a command. Stuff like, if I want to say feed a command a file, or feed output one command to another command. You have standard out, which is the data out, it's the best way to say it. And then you have standard error, or just the error, which is for human reading and usually not for interpreting by a program. Standard out might be machine readable, standard error almost never is. So a couple of examples. Standard in is the input, which is, some is given directly by the user or from being piped in. Some represented as a dash. You see the echo, which, if you don't know, just prints what you type it. Its echo is given a standard in, and then it's being piped into command. In this case, SHA-1SUM, which is just hashing it. The string standard in got sent into SHA-1SUM, and that was sent in there. And then at the end it says dash because it's reading from standard in. Standard out is the data that's being output. So if you cat a file, it says this file exists. It cats the contents. That's the output. Seems pretty reasonable. And then errors for the user. If you cat a file that doesn't exist, it'll say no such file directory, and that is in standard error. This is helpful because you can separate them off, so you can process them independently. You have, shell redirection. This is sort of specification for how file descriptors work. Not really. You have your command, which and then you have the file descriptor, which can be a number, which is 0, 1, or 2. You never put 0 there. That wouldn't make a lot of sense. I guess maybe you could, but usually either 1 or 2 there. If you don't put anything that's implied to be a 1, then the output file path. If you're piping into a file, if you use one of the greater than signs, one of the greater than signs you have you overwrite the file or create it doesn't exist, and you use two of them, it'll create or append to the file, which is great for like a log file. If there's no file descriptor given, it defaults to 1, and you can combine them. So you can say, you can I mistyped that. You can do 2 into &1, and then you can do like 1 into out file, and they'll both go together. If, again, great for logging mostly, not for like being readable. So you see, you cat out, then you echo text in out, and then it has text in it. I hope files at least make sense. Next up, else files. This is executable link format. All you really care about is it's an executable. It's not that fancy. There are 3 types. This is stuff from Daniel, so I'm going to read this a little closer. There is relocatable. Oh yeah, so relocatable is compiled libraries, I believe. There was something, you know what, I'm not even going to know what that is. Executables are things you can run. That's what you're all familiar with. And then shared objects or dynamic, those are definitely libraries. Just going to ignore relocatable. You have segments and sections. This is stuff you'll learn in CSEC 201 and 202, for the record. At least somewhat. You have segments, which are for loading executable files, and sections, which deal with like importing other things, basically, like libraries. And see, Daniel talked for more information. Clearly, I know nothing about EL files other than their executables. And quite frankly, I don't think you need to much either unless you're doing like reverse engineering stuff. The services. These are programs that are managed by the operating system. They are run, and the background tasks. They're things that make your computer work, essentially. There are things called daemons, which, to be pedantic, are things that are on boot, or services are on boot. That is kind of loosely used. They run in the background, which is to say they, again, you don't see them. They're what make things work. You can manage them quite a few ways. You use systemd, our below in that system. Use OpenRC. That's an alternative. You can also use runit. Sure, and sysvinit or sys5init. That's like the old one. They also work. Just keep that in mind. Now, making a systemd service file. You have yourself. It's pretty human readable, which is kind of nice, admittedly. For all the crap systemd gets, their service files are very easy to read. You have the unit, which has the description and certain requirements. You have the service section, which is like what's being run, the type of service it is, and the install, which is just like information about when it should run during the boot up process. Like, is it the first thing to run? Does it run once users are, let's say, like once the graphical interface is up, or so on. Information about service. There are 2 commands. There's service, and you type a service name, then status, or systemctl status service. You see in the service, there's stuff like the things that really matter are like the snippet of logs. There's the path on the very top. There's the, like, what says loaded. There's the actual path of the service file. Super great time to figure out, like, what is it actually doing. So I can call a service whatever I want. Doesn't mean it's doing what you want to do. The process ID is nice. Most other things don't really matter. The active time, too, if you want, like, why is this thing restarting so much? Now, quick digression. People like to get picky about this. Some people say, like, service is the old command, and why are you using systemctl? And that's fair. Systemctl only uses systemd systems. In fact, any command that ends in ctl is probably systemd. Service is, generally speaking, pretty universal. It runs basically anywhere. Anywhere that runs services anyway. Like, not an Android phone, presumably. Both will manage services in both systemd and other services. They will manage ones that are created via older systems or ones that are created via systemd. Systemctl has a few actions that a service can't do, like mask and disable, which is how you like basically prevent either start it on boot or to stop it from or to just completely like stop it from block it from running. In pre-systemd times, you just did this manually by moving or linking files, making symlinks. Here's the thing, doesn't matter which one you use. In every systemd-based system I've seen in the past half decade or more, they're both options and they exist and they work just fine. Systemctl, systemctl can also do like user services, which are a big pain in the ass, and I don't think very few will use because it's a pain. Systemctl has a format in the systemctl, then the action you do, and then the service name, and you can list multiple services, which is nice. But service is service system action. Now, those seem kind of mundane, but for my use cases, I'm very rarely controlling 4 services at a time. But I am very frequently switching to different actions like restart, start, stop. And so for like a typing point of view, having to skip the service to go to the action part is much nicer. So that's why I like service. That's just me. Now, let's say you don't have systemd, or older services that are using the legacy compatibility systemd is built in. You have the rc.d directories. They're technically legacy, but they're not going away anytime soon. At least not as far as I'm aware. They're pretty fundamental. Services are just shell scripts. Like, that's all they do. They're scripts. They just run. Super simple. There's generally always assembling to something in etc/init.d that is important for, that's just because it helps with organizing, and you can have things that run on multiple run levels. Each time a run level is hit, it runs all the services in order, like sorting by file name. So you have they all start with an S or a K. So like SO1 will start before SO2. So you have like SO1, SSH, and SO2, I don't know, GNOME or whatever. Just GDM anyway. Run levels. Again, these are mostly antiquated in systemd world, but they still do exist. 0 system halt means shut down. 5 is running under a GUI. The rest is usually a form of booting up or some other being turned on. You really only care about 0 and 5 90% of the time. Or maybe 0 and 3. So as a quick example of a, legacy service. Now, clearly, can't say anything, so we're going to enhance. Oh, first we're going to look at the sections. Top of your service info is all the comments, like the name and the default run levels as it's shipped from factory. Then in the middle, you have the functions, like the do start and do stop. So those are which actually run when you run start and stop. And the end is a switch case statement, which is like a big if else, if you don't know what that means, of all the different things you could give it, like start, restart, status, stop, etc. But now I'm going to enhance, because I can't read anything on the tiny text. Look at the case statement here. You're going to have the, when you case $1, this means the first argument after that. So literally when you run service, say SSH start, you just run etc initd SSH start. That's all it would do, which is why it's so easy to work with. Start would just run the start function. Restart and reload aren't implemented, which doesn't matter. Stop, the status does nothing. Stop just runs stop, and then there's usage. Pretty if you look at a shell script ever, you've probably seen something like that. You have do start and do stop, which is literally just, this is rc.local, which is just running a script. Basically, it's run the script, return. And then for shutdown, it's run the shutdown script, return. Pretty simple. Let's say you want to schedule something. There we go. Cron tab. You can also do systemd with timers if you want. I don't know. You have cron, though. It's pretty straightforward. Exists on almost every Linux system I can think of. You run it with cron tab-e, which gives you a big file to edit, which we'll go to in a second. Their user cron tabs are stored in var spool cron. This is great for competitions. If you just want to see every single user's cron, cron tab, instead of going through each one like looking by hand like an ape, you just look at the directory, and if there's the name of a user there, they have a cron tab, and if there isn't, they don't. And also there's stuff like etc cron daily, and those were system-wide things. There's also, I think, hourly and like weekly. There we go. So per user cron tab examples, which is the one you deal with 99% of the time, they're stored in var spool cron username cron tab. Edit them using cron tab key. I guess you might not have to. You could probably edit it directly and then restart the service, but why? I guess if red team bricks your command. This is the format. You have 5 numbers. You have minute, hour, day of month, and day of week. And then you have the command you're running, right? And so star means any, and you basically ignore this. So you have all stars, it runs minutely. If you have a 0 in a minute, and then rest stars that run hourly. And then for, say, like, I want to run this thing weekly at 6 p.m. Every Saturday at 1800 hours, which is 6 p.m. Make sure your time zone on your machine is set to your local time zone or account for UTC. Minutes being 0, and any day of month, any month, run it. Run that script. Pretty easy. Here's a my cron tab. Store an etc cron tab, you edit directly, and it's, at least as far as I'm aware, and it's basically the same. The only difference is you have the user in the middle. Usually it's root, but also me, a normal user. That's all pretty simple. Half time I edit that file and I forget to put a user in there, and then it doesn't work, and I'm confused as to why. And then I look back and remember I forgot something. Anyway, kernel space versus user space. Again, sort of, I have the same opinion of this as I do the OSI model, which sometimes is a little bit controversial, but like, you need to know like 2 of these and nothing else matters. Like, the difference between ring 1 and ring 2, yes, there is a difference. Does it matter to the average person? No. Ring 0, that's Temple OS, or also known as the kernel. You have ring 3, well, I start with the order I put them on the list, which is user space. That's where user stuff lives. Anything you do as a user, unless you're editing the kernel, so unless your name is Sherrod, everything you do in your system is probably in ring 3. Applications, yeah, stuff you actually use. Ring 0 through 2, these are, yeah, it's device drivers, kernel code, kernel modules. Really, in my head, I have ring 3 and I have ring 0, and anything else in the middle doesn't matter. It's effectively one or the other. Same as OSI model, you know, anything above like layer 4 is just kind of vague. Anyway, system calls. They have functions that are defined in the kernel. The kernel does everything in Linux. That's not true. Systemd does everything in Linux nowadays. Anything that you want to, say, read a file or listen on a network port, if you want to do a thing that is not just edit your own memory that is allocated on the stack, you're running a system call. And even that is probably also a system call at some level. It's how the kernel and from out most processes get things done. glibc or libc acts as a wrapper and is the thing that almost everyone uses. It is not great, but everyone uses it, so everyone uses it. I'm not going to suggest alternatives because I don't care. Basically, this means that you have a standardized connection between the kernel and the programs. And it's accessible via C code instead of having to do it manually. strace is just to trace or print out syscalls. So you can run a command with strace. And you can see all the calls it's doing, which is great for reverse engineering. Or just seeing, is this thing frozen? Done that plenty of times too. But kernel modules. So custom additions to the kernel. There are plenty of modules that are included with almost every install, and then you can also add your own. For like, you know, you have a Realtek Wi-Fi card, you've dealt with these plenty. .ko files are kernel objects. They are relocatable files. And they can be loaded with insmod. So basically, I can give you if it's compiled for your kernel, I can give you a kernel object, and you can load it into your kernel, and you can use whatever device that kernel module helps you with. Also often managed the modprobe command. You have like modprobe if it's already installed but not running, or not initialized, whatever, you can run it there. You can remove it. That's great for also diagnosing. Like every once in a while on a laptop I had, like the keyboard would stop working. I just would bounce the the I squared C bus, I think, or something. Whatever the keyboard uses, I just would bounce that module and then it worked. Doing that without a keyboard was interesting, but that's a different topic. And also just have stuff like EDR, which is endpoint detection and response, which is how you continuously monitor for malware on more advanced systems. Rootkits, so red team, anti-cheat software all work. If you ever wondered why does this game need root access to install, that's why. Because it's putting anti-cheat in your kernel, and basically it's making sure that there's no, to oversimplify massively, it's making sure there's nothing between your keyboard inputs and the game that could be causing problems. Net filter, it's just how the kernel intercepts packets. It can interface in user space with plenty of applications. There's IP tables, which is the thing basically everyone uses. Those are the uncomplicated firewall, or UFW, which is a wrapper, which makes firewall rules super easy. It's, of course, a little more limited, but still, if you're just like, I want to block SSH, you're going to use UFW. Basically, when you see net filter, think firewall. That's basically all it is. You can do complicated stuff with it, but for most purposes, it's just firewall. And it's NAT sometimes, which is networking stuff I won't go into. You have eBPF, the extended Berkeley packet filter. It's built on BPF, which is packet filter packet analysis. And eBPF is basically a way to load on stuff for the packet filter to run from user space. It's usually written in C. There's some Python libraries for it too. Basically, it's an API for communicating between user space stuff and kernel space. Think this way: you can write a C program that acts as a firewall. Hi. Yes, thanks, Brickhack. Right, eBPF. You can write a C program, and it runs as a firewall at the kernel level, and depending how you write it, it can run with hardware acceleration too. So you can do a ton of crazy stuff with eBPF, because essentially it's a program running on the kernel level with some restrictions. But yeah, it's very flexible. Anyway, you have SE Linux. Security enhanced Linux, who doesn't want that? And it's developed by the NSA originally, as per a lot of things when you start looking into them. It's at the kernel level. It's an application of the Linux security module, which doesn't really mean much to most people. It's mandatory access control. Basically, at the kernel level, if you tell a program it can't do something, if a system says this program can only, like say, OpenSSH can only access its config files, not say, the shadow file, the password file that runs. It's set by the system, not the user, and root cannot bypass it. Doesn't matter what user you are, you cannot bypass it directly. You can turn it off if you want, but you can't bypass it. You also have discretionary access control, which is user control permissions, which is more what I was talking about earlier. And then you have your config there. That's not always in that place. It depends on your system. And defines different permissions, different applications. Basically, SSH can access these files. FTP, pro FTP can access these files, etc. Anyway, that then gets into authentication. We're going to get access control. PAM is what does everything. It's a pluggable authentication modules. All that really means that you can configure PAM a lot with modules, and you can do a lot of crazy stuff in there, including red team stealing your passwords. You have a stack of modules that determine authentication, a set of rules to go through. These are shared libraries in a sense that are loaded in, and they're configured under etc pamd. Anytime you see .d, I might get this later, but anytime you see a thing.d, this means it's a directory. Usually means in the past it was a file, and then they got tired of it being a file because they had like a million lines, and they made it into a directory. You give multiple modules to the user. You can do multi-factor authentication. You can have, say, Kerberos and Active Directory logins. You can do a ton of stuff. You can say, you go to Backdoor and say, hey, if the password is password, let them in no matter what they do. Even if it's the wrong password, let them in. Module list is evaluated from top to bottom, as a list, as you'd expect. And similar packet filter tables, basically. So here's an example of one, of the module itself. This one has a backdoor in it. Well, sort of. So we're just saying, like, if there's a password, that's a backdoor. Basically, is, you check the password normally, but also does if you have a certain password put in there instead, it'll bypass no matter what the real password is. It's that simple. It's a little more complicated, but that's all that matters to you. You have your PAM configuration, which is just a list of files. The only ones you really care about are auth. All these have common for them, so common auth, common account, common password, and common session. Common auth is authentication steps. Account checks for stuff like, is your account expired, etc. Password is changing passwords. And session is additional setup for, like, mounting your home directory, stuff that is irrelevant. Basically, you care about auth. Auth is the one that you care about 90% of the time. And these common files are ones that are included by multiple programs. There's specific ones for stuff like SSH would be here normally if they had SSH installed, but we don't care about SSH. But SSH is mostly just inferring something else. There's no point in re-implementing all of password checking for SSH. Here's a question, like, does this PAM work? This is in common auth. I think all these will be in common auth. You have PAM Unix, which is what basically checks your password. You have PAM deny, which makes sure that if nothing happens, it fails you out, and then otherwise you get permitted. It's kind of weird. You have a deny and then a permit, but because on the top one you have success one, which means if it's successful, you skip one next step, and then the default is just ignore. And yes, this works just fine, because if the password is correct, you skip PAM deny and go straight to PAM permit. And if you fail, then you go to PAM deny, and then you're denied. Does this PAM work? The same, except success is set to 0, as you might expect. No, because success is 0, we skip 0 modules. Basically, this is just run this and then ignore whatever it says. Like, whatever it says doesn't matter. So you always run PAM deny, which is obviously not good. Now, does this work? Now success is back to 1, but now PAM deny is listed as optional. And no, because optional is too loose, because if the password's wrong, it'll run deny, but deny is going to fail, and no one's checking what deny is doing because it's optional. That's good for, like, Kerberos login. If, say, you have a local password, but then you want to also initialize, like, a Kerberos, or I use Kerberos, what I'm using as an example. Well, someone at central authentication, say, like, initiate my session whenever I type in my password normally, so you don't do it manually. This is what optional is useful for. Does this work? What did I change here? Back. Now it's sufficient. Will this work? No, because all passes are allowed. For the same reason, because sufficient is still, sufficient basically means if it goes through, that's good. If it doesn't go through, then it doesn't matter. It won't actually deny you. Does this PAM work? Now instead of a single keyword, you have this big bracketed string. And the answer is no, because that's actually just sufficient. They are defined in the man pages, actually, as being required, requisite, sufficient, optional. They're just shortcuts for what those are. This is on my system, which is a bit more advanced than that one, but the point is that, actually, they're all the same options. This is, what happens. There is keywords because those are the 4 options you almost always want. And you see those are the same because it is just sufficient. Now, some quick 7 tips and tricks that are very useful. You have a keyword for a thing that is configured somewhere, but you don't know where it is. You have my best friend. Speed and power. No. grep. grep tac R specifically. grep is a general regular expression program. If you know regular expressions, good. If not, just think keyword. Don't get complicated, just put a word in there. You use tac I for case insensitive as well. So you have your keyword. So let's say a keyword could be basically anything. And then you can say you want to find where anywhere user is referenced in RITSEC, for instance. Like, where is the root user referenced, or the SH user reference? It is a recursive grep, so it finds any reference a thing in a directory that you give it. Usually great for using RITSEC, but I'll explain about other uses too. And it's got me a job before. Real story. I was doing something for Forrest, and his test was basically he had a weirdly mounted directory. He had to figure out how it was mounted, and I didn't know what he had done. I just met the guy, but I went to mount. So like HomeFS is not a real thing I know of. So I grepped through RITSEC for HomeFS, found the init ramfs configuration, and then found what I needed to do. So that got me a job that paid pretty well on campus my freshman year. Arguably paid too well given I was a freshman. Anyway, that's all. My end card didn't get put in here because I did it last minute. Questions? I'm gonna go with none.